Welcome to class, Friday, June 5th, 2020. We're in the home stretch. Go ahead and type me a couple things that you remember from Monday or Tuesday's notes about permutations and combinations. So this is a lot like the problem you just did with Marco's class schedule. It is also a permutation because the order that you put your personal identification number digits in matters. The difference being that Jasper here has 10 different digits that he could use for his PIN number, which makes N 10. But we're still only picking a 4-digit number, which means K is 4, which means we're going to have to do some adjustments for the ones that don't get used, the numbers that don't get used that are left over. So how do we do it with the decision chart? First digit, second digit, third digit, fourth digit. How many different possibilities are there for the first digit? There are 10. I am not allowed to repeat a digit. So once I have used the first digit, it cannot be used any longer. So how many possibilities do I have for the second one? 9. Now that I've used those 2 digits, I cannot use them any longer, so I only have 8 left to choose from when I'm choosing my third digit. And same kind of thing happens for my fourth digit. 10 times 9 times 8 times 7 is 5,040. How are we going to do it with factorial? Okay. Here's how it works with factorial. 10 factorial divided by 6 factorial is the same as 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 6 times 5 times 4 times 3 times 2 times 1. 6 divided by 6 cancels, makes 1. 5 divided by 5 is 1. 4 divided by 4 is 1, etc., 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 which makes 10 factorial divided by 6 factorial equal to 10 times 9 times 8 times 7, which is equal to 5,040. So you can see that this looks a lot like the decision chart we had for the first part of this problem. In fact, it's identical. Okay, this is a permutation without repetition, because the one design isn't going to win first place and second runner-up. So the formula that we learned for permutation without repetition, N is 52. K is 4, because we're doing the best, plus this runner-up, and this runner-up, so that's 4. And if you put that into your calculator, 52 factorial divided by 48 factorial, 6,497,400. Okay, if we're going to solve this like a permutation, if we're going to say that we care who got first prize as opposed to who got seventh prize, we're putting our winners in order. That's a permutation. To solve it as a permutation, N is 16 teams, K is 7 prizes, 16 factorial divided by 16 minus 7 factorial, which is 16 factorial divided by 9 factorial, which is 57,600. 657,600. We could also choose to solve this like a combination. We can say 7 winners, they all get the same trophy, they all 7 get the same cash prizes. We're not differentiating between first place and seventh place. That would be a combination. And still is 16. K still is 7. I will accept this either way. Combination formula is n factorial divided by n minus k factorial times k factorial, which is 9 factorial divided by, 16, sorry. Okay. (16 factorial divided by 9 factorial, k is 7. 7 factorial. To put that in our calculator, we've got 16 factorial divided by 9 factorial, 7 factorial, 11,440. You will always notice the combinations are much, much smaller. 11,440. We had millions. We had 57 million something. Now we have 11,000. Combinations will always be much, much smaller than permutations. Okay, this is also a permutation without repetition. K is 3. The numbers 0 to 35, that's 36 digits. So n is 36. 36 factorial divided by 36 minus 3 factorial, which is the same as 36 factorial divided by 33 factorial, which is 42,840. Okay, this was a little bit on the tricky side because our first number, this is exactly like the previous problem, but our first number cannot be 0. So instead of our decision chart looking like 36 times 35 times 34 for our 3 digits, this one cannot be 36. We don't have 36 digits to choose from. we cannot use 0 for the first digit, so we only have 35 numbers to choose from. So this looks like 35 times 35 times 34, or we could write it as a factorial, 35 times 35 factorial divided by 33 factorial. Either way, our answer is 41,000. $650. Okay, now the difference is she can repeat numbers. This is a permutation without repetition. The formula for a permutation without repetition has no factorial in it. It's n to the power of k. So n is 36, k is 3. So that's 36 to the power of 3, which is 46,656. This is a combination. N factorial over n minus k factorial times k factorial. So here's n, 11. Here's k, 3. So 11 factorial divided by 11 minus 3. Factorial, which is the same as 11 factorial divided by 8 factorial, 3 factorial. Be careful if you're putting this into a calculator, if you're not using a fraction, if you're using the division bar, put this in parentheses, otherwise order of operation is going to mess your answer up. You should get an answer of 165. She can adopt 3 kittens out of the litter of 11, 165 different ways. Our child only has 3 magnets. So, 1A, 1B, and 1C. So can a child make AAA? No. The difference is the license plate triples is a permutation with repetition. Repetition is allowed. And the 3 magnets on the refrigerator door is permutation with no repetition. Okay, if we care about the order, that's a permutation with no repetition because you can't repeat people. If we're just 3 spirit committee members, we don't care the order they're in, that's a combination. Okay, you can repeat numbers, permutation with repetition. You're using square tiles, so there's no repeats. That's a permutation without repetition. Numbers are always permutations because the digits, the order the digits are in matters. It'll make a different number. Last one. And this is another basic combination. You're just going to use your combination formula. Again, remember to put the bottom in parentheses if you're entering it into a calculator without a fraction bar. I hope these were helpful. Reach out during office hours today if you have any questions, or send me an email or a text. Have a good weekend.